All right, so we're continuing talking about composition of functions, but we're going to take a little side trip and look at some information that I have in my GeoGebra book for this topic. And so we've got chapter 3.4. This is linked, remember, from the D2L page on the lower left side. And we've got several options for composition of functions. I want to start maybe with this dynamic illustrator here. So we've got two functions, and I think you can change these to pretty much whatever you want. And it will show you can either do f of g of x or g of f of x. And as you do the slider to calculate a particular value, so this one, the g is the parabola, f is the straight line, and we're going to do f of g of x. So first, we're going to go out to x. We're going to find what the g value is, which there's some positive value. And we're going to take that y value and use it as the input for, so now we're at that x location, and we're going to go see what the f function is at that location. So this is kind of trying to visualize what's going on when you do a composition of functions. We have, this is good for like basically a table or a graph. It's kind of like a little self-quiz. So you can say, okay, let's see, g, f is the blue, pink function, g is the blue. So g of f of -7. So we're going to go back here to -7 and say, okay, what is f of -7? Looks like it's -1. What is g of -1? Looks like it's -3. And we're going to put that in, and it's going to say, hey, yay, you got it right. And then I think you can press the button for a new problem. And you can kind of see the functions that they use to come up with these points and stuff like that. Then there's a version of this with algebra, right? So we've got two functions here. It's going to ask g of f of 5. So you've got to evaluate that, put it in here, and if you press the new function, it'll give you a new combination of stuff. So it's kind of cool for self-tests. So we're going to do another example here. So we are looking at a quadratic and a linear, similar to what we had before. And so first off, we're going to say, okay, what's the domain of f? Go back. Domain is going to be all real numbers for f, also for g, so that's good. Okay, so f of g of x. So f is eating g, so we're going to use, so this is going to be f of 4x minus 3. So we've got 4 something squared minus something plus 10. And so what's going in for the input? 4x minus 3. All right, so we really just need to simplify this. Let's see, this is going to be 16x squared minus 24x plus 9. You can fill that out on your own. Minus 4x plus 12. Don't forget to distribute. Oops, not 12. Plus 3. And then plus our 10. So we're going to do a little more simplification here. 4 times 16 is 64. 4 times 24, that's 48 doubled, that's 96. 4 times 9, that's 36, minus 4x plus 13. 3 plus 10. All right, so our x squared terms is just the 1. We've got 96 minus 4 for x terms, so that's minus 100. And 36 plus 13 is going to be 49. And that may or may not factor. We don't really care. Okay. What about doing the other direction? G of f of x. So this will be g of 4x squared minus x plus 10. So we're going to look at our g function, 4 times whatever. I'm going to make that box a little bit bigger. Minus 3. So 4 times, well, let me go write it in the box. That would make sense, right? 4x squared minus x plus 10. So now we got to distribute. So we will get what, 16x squared minus 4x plus 40 minus 3, 16x squared minus 4x plus 37. And so you can see that these are not equal to each other. So order matters when you're composing functions together. So in general, not always, there's some special cases, f of g of x and g of f of x are not the same. We'll say in general. Okay, I think I've got one more example here. Yeah. And then we'll talk a little bit more about domain, but we're at the 5-minute mark.